Prasad joined, Ala Suresh joined, Venu joined, Sivaram Krishna joined. Only 4 people joined. Vasudev, what he is doing? Vasu joined. Ask others to join. What they are doing. Ask them to join. Okay, Vanilla, you concentrate. Okay, start.
Good morning, everyone. Myself, Lakshmi Kuruguntla. I am very glad to initiate this program, which is My Scholar's Voice. So with the support and supervision from our faculty of EC Department of SRM University, we are going to initiate this program, My Scholar's Voice. So the main objective of this program is to project the expertise of the researcher from their domain and to motivate the undergrad, postgrad students and fellow researchers. In addition, one can get familiarized with this research going on different areas in the EC department. This will surely develop the interest towards the research apart from the academics. This program is extremely beneficial for the presenter as well as the participants, and it also helps to build up the strong research network where they can continue research collaboration. And today, one of my research scholar, Mrs. D. Anila Chandra, who is going to give the presentation. And I'm going to tell about the speaker. And Mrs. D. Anila Chandra is pursuing her PhD degree under the guidance of Dr. Karthikeyan sir. And she had received the BTech degree in the ECE from Amrita Vishwavidyapitham, Coimbatore. She then joined Robert Bosch Engineering and Business Solution Limited, Coimbatore, as Associate Network Engineering. She received her MTech degree in Embedded Systems from the KL University in 2017-19. Her research interests include machine learning, signal processing, and embedded systems. And this program will be very helpful to all the students who are pursuing MTech, BTech, and our fellow research scholars. And it's very happy to initiate this program from our EC department. And now, Vanilla will start the session.
Thank you, Lakshmi. So, good morning, one and all. I'm Vinila and I'm doing my research under Dr. Karthikeyan in the Department of ECE. And I'm very happy to give my first talk in the My Scholar's Voice session. So, let's go into session. I'll start sharing my screen. So going into the topic, so today the topic for the session is Introduction to AI ML with Python. So like most of you might be aware of what is this AI ML and what is this Python. So you might have heard about these terms. And now coming into like what is this AI ML with Python, why we are going for AI ML, why now this AI ML has come into, and why we are going with Python, not other languages. So all this introductory session about these technologies and programming languages will be given in this session. So now going into the contents, the flow of the presentation goes this way. So first I would start with what is AI, ML and DL and what are the subfields in that, and what are the applications, different applications we are going to implement using this AI, ML. And next, why we are going for Python and how this Python is being helpful in machine learning algorithm implementations. And with examples, we would see all these like with 2 examples, I would explain about these how this networks works, like how do we train, how do we test it. So you might have heard about all these terms. So what actually we're doing while training, while testing and all, and also with examples. And I would also focus on my my research which is based on this AI ML techniques. So I would give a briefing about that application. So going into the content, so what is AI ML? So since the invention of computers and machines, there is a capability to perform various tasks has experienced an exponential growth. That is, while exploiting the power of computer systems, like our curiosity, like human has a curiosity to let him to think, like if machine can think like that, so can a machine think, and they can act like a human does. Yes, so there's the development this of AI took place. So it's the way of making a computer to work and to act in a similar way as an intelligent human think. So that is what this AI ML. But this AI ML was there from the long back, but due to the computational lack of computational efficiency and lack of vast amounts of data, this has not come into developed earlier. But now in recent years, due to the availability of large amounts of data and increase in the computing machines, increase in technologies in computing machines, faster performances, so due to all these reasons, this AI ML has come into picture these days. Now why we are going for AI ML techniques. So what is the advantage of going into this, learning this, or implementing this in real life? So what does it does actually? So now, we know in daily life we deal with huge amounts of data, and we human brain cannot keep track so much of data. So that is where we need to automate the things. So there comes this AML technology, where this technology can learn through the data available. And also, like, the data keeps on changing. So with the changing data, we have, like, they have, like, we or the machine have to adopt itself. So this technology can also teach by itself with the changing data, with the changing dynamic data. So it can teach by it can learn through data, and it can also teach, and it can adapt to the dynamical data. And also it should be able to respond in real time too, because that is the most important aspect. Because in real time, if the technology is helping a lot, then it's such a great thing. So this is also being achieved in real time, this, like, by using this technology, like by using, there are something called neural networks, which we'll be discussing later point of presentation. Now with this, we can analyze the data, and then we can make the mission to respond in real time too. And next thing is, it can achieve accuracy too. Accuracy here in the sense, like, for example, if you take medicine field, like, with the help of this neural networks, you can actually diagnose diseases such as cancer from the MRIs of patients. So from, you can collect the data of MRIs of patients, and you can actually diagnose, like, which medicine to give. So we have large amounts of data available. So based on that data, we can actually aid the doctor in in suggesting the medicine, or to like identify the disease also. So it has achieved such a good accuracy also. It has been proven. So these are all different, like, reasons to study this AI ML. So not only this, we had many. So these are just a few to name. And going into, like, subfields, there are many subfields, or like two subfields mainly of AI. So, like, not everything, like AI ML DL, so they use it abstractly, but there is a, like, difference between, like, the slight borderline differences between these technologies. So what is AI, what is ML, what is DL? So coming into AI, like, if you take a self like driverless cars, it comes under an AI thing, because it's like fully automated. That it can sense, it can give the reason, it will act accordingly, and also adapt according to the situation. So if there is an obstacle, it actually drives its steering to the other direction. So it is, as a whole, it is an automatic mission. So this is where this AI is. And coming into the machine learning, so what this is nothing but this ML we are using to implement, implement this AI AI products. So these are nothing but, like, they are the algorithms. So we design these algorithms for, like, to enable the mission to improve its experience. So we give the data, and over the time, the mission, these algorithms are useful to enhance the performance and improve their accuracy over the time, with more exposure to data. Like, if we expose them to more data, so then they would perform in a good accurate manner. So these are the algorithms that we use to implement this AI missions. And coming into deep learning, so it is also a subset of, this is subfield of mission. ML and DL both are subfields of AI, and DL is subfield of, again, comes under machine learning. So whereas what does this, what do we use in this deep learning is, like, there is this more similar to the with neurons in our brain. So how they connected, so the architecture is also inspired by the architecture of the architecture, like, the connections of the neurons in the brain. And in such a similar way, how we learn, so the architecture also learns in a similar way. And this deep learning, using deep learning, you can extract more number of thin, like, similar features, like abstract features, so which cannot be done using ML. Also you can do it in using deep learning. So, and where you have, and this is also, this DL also we use where we have large amounts of data. So if there is vast amount of data, then you can go for deep learning, and then implement your. Now, with an example, I would explain, so it would give a better understanding now. So, for example, if you take, you can, by seeing it, we can say it's a square and it's a circle. So, but before going into telling the square, first, what we would check if in this diagram to tell if it is a square or not. So first thing we do is if we check if the figure has a 4 lines. So yes, it has 4 lines, and you check if they're all connected and they are closed. Yes, they are connected and they are closed. And in the next step, what we do, we check if they are perpendicular to each other. Yes, they are perpendicular to each other. Then you come to a conclusion that it's a square. So here, what we are seeing actually, we are seeing the nested hierarchy of concepts. This is where that is what DL does. It goes for the abstract features, like with multiple layers. We actually go in this way. Like we have checked for the in the first step, we have checked it has a 4 sides or not. So in the similar manner, in using deep learning algorithms, also we would check in the first step if it has 4 lines or not, and then in the next step you check if it is closed or not, if they are connected or not, and in the next step you check if they are all perpendicular. So in this way, deep learning algorithm learns the features in the similar way as how we are identifying is it as a square. And coming into this second example, if we wanted to classify to like if we wanted to recognize if it is a cat or a dog, how can we do that? So here I would tell, so if it is if you're using ML, how we are going to do it. If it is a DL, how we are going to do it. So both I would explain here. So is it a cat or a dog? So how do we identify that? Like for instance, if you are using machine learning, we give explicitly the features, like if it has a tail, if the tail is straight or curved, if it's straight, it's a cat, if it is curved, it's a dog, if it is whiskers or not. So if it has that, if then it's a cat, if not, if that is a dog. So you give the input, like these are the features that are useful to identify as this is a cat or this is a dog. But where, and you define, that is you explicitly define all the features and you let the system to classify, and you ask the machine to classify. You give all the features and you ask the machine to classify if it is a cat or a dog. But whereas in DL, what it does is it does the entire job end to end. So you need not explicitly give the features. It automatically finds which features are most important, contrast to ML, and where in ML we have to give manually, but here you need not give it manually. So it's an end-to-end process where by using this deep learning techniques. And coming into this third example also, I here suppose if you wanted to detect and you have to recognize and detect what here was this is human. So how does it how ML does it, how DL does it? So in if you're using machine learning algorithms, how we do is first step is we do the object detection. So first you do the detection. So like some object is there or not. So some using some algorithm you detect it as some object is there here, and by using some second algorithm, you recognize it as a bus, it's a human, it's a car, it's a car. So you recognize. So you have to use two algorithms like this for detection and for recognition. But whereas when you use deep learning, it gives end to end, it does end to end job. That is the location along with the name of the object is what you get when you use these deep learning algorithms. I hope you are clear with what is the difference between these three. For example, in machine learning, you can take the example of Siri, Alexa. So all this comes under this machine learning. And also you might have seen this shopping websites, Amazon, Flipkart. So based on your search criteria, it would recommend us the similar items. If, for example, if you're searching for some TVs, so it would give us the suggest that the most popular or mostly bought television. So it is giving us the suggestions. This is all the ML running behind the recommender systems running behind the apps. So these are all the different this is subfields of AI, and more focusing on ML here. So coming into machine learning, so we had two categories in machine learning. So one is supervised learning and unsupervised learning. So what is this supervised and what is this unsupervised is? So supervised learning means we here actually develop a predictive model based on both input and output data. That is, you have an input and you also have a corresponding true value for that particular input. Say, for example, if it is a cat or a dog, you actually label them with a name, like it's a cat, it's a dog, and you give it to the mission and you ask them, like you train it, and you when you give a new set of image, like data, new kind of like cat in some different position, it should be able to recognize. It's like more of like with experience and with more exposure to data, the system actually learns it and gives us the it predicts the data. And in supervised learning, we had two categories, like two sides: classification and regression. So here, classification, it means if the output, if based on the response, it is actually divided into classification and regression. In classification, like when your outcome is a continuous variable, it is regression. If your outcome, if you wanted to, if it is a discrete, then you go for classification. And similarly, contrast to the supervised learning, in unsupervised learning, you don't have the true data. So you don't know if this is a cat, you don't label it the cat. So you don't have the label data here. If based on the input patterns, so similarities, and based on some distances. So we have so many algorithms in for unsupervised learning also. So based on the similarities, structures, and all, it actually grew by itself based on the input data. So only input data is given here, and no label data is present in unsupervised learning. So that is what there it's divided into clustering. So under clustering, we had many algorithms: Gaussian mixture, hierarchical, neural networks also comes under, you be used for clustering, and hidden Markov model, k-means. So these are all the different algorithms for unsupervised learning. So I would actually explain with an example for classification and regression in the further coming slides. And these are all the different applications like medical diagnosis, stock market trading, online fraud detection, virtual person assistant, email spam and malware filtering, self-driving cars, recommendations, traffic prediction, speech recognition, image recognition. So all these are all the different applications of machine learning, and they're widely being used now in different domains. And coming into this now, okay, we had different applications in place. So we had scope in different areas also. So not only in electronics, it has been in every domain. This machine learning can be used. Where there is data, you can use this ML. So now how we are going to implement these AI applications? So we do have different programming languages like Lisp, Prolog, C++, Java, and Python. So we do have many programming languages to implement these AI applications. But among them, Python programming has gained a huge popularity because of its simple syntax and less coding. So you, anyone who doesn't have the basic programming language also can go and learn this Python from scratch, and then they can work on it. So this is that simple and less coding and less syntax. Syntactically also, it's not that complex. And there are also many libraries for AI projects. And since it's an open free, anyone can use this open source. And if Python, even the Python code is open thing, you need not pay anything, and you had lots of support also in the web available for this. Python, and you actually can change source code is available for this Python. You can actually change the source code, and you can now develop your own programming language, develop improvement in the existing programming language. So it's such a uh, free and open kind of programming language. So that's the reason why it has gained so much popularity. And so and also there are many libraries, also inbuilt libraries for AI projects are also available. So the basic algorithms and all also are already there in the inbuilt library, so you can make use of them and work on them also. And that is efficiency also is more, and reliability and speed is very good. And this is the one Vidor Ranwanson was the one who created the Python in 1980s, and it took this 20 years to get this much popular in this field. Now going to the Python, so as I said earlier, so these are the features of Python. It's in high level, interpreted, interactive, and object. So you can see C is a functional oriented program, and C++ is an object oriented program. So, but in Python, it has all these features. It is functional, it is interactive, it's object oriented, and it's a scripting language. So all these features are there in the Python, and so that's the reason why we are going for this Python for AI ML applications also, for implementing this AI and ML. So for learning, so everyone who doesn't have a programming language, as I said, if they just go and check on the syntax and all, they can easily understand the logic behind it. And the maintenance is easy to read. And there is the most important thing is we do have many libraries in place and ready, and it's portable, so you can work on any OS. It's all well established now. So now we'll see how we run this Python script. So we do have different options available. So one is interactive mode. So I would show you how do we do this now. So there are different like interactive mode, command line, text editor, and IDE, and Anaconda Navigator. This is an ideal tool for performing data science tasks because we like managing the packages and all. It's very easy when you use this desktop GUI Anaconda. Now we'll see the interactive mode. So how do we work on it? I would show you. So you can just pick command prompt and you can go inside and give like Python. So it is giving some 3 point, it's a version that has been installed here, 3.7.6. And now if you wanted to, now you are in this Python mode. So print, so this is interactive mode. Just I'm giving one command, hello world. So you can see hello world is being printed. Similarly, you can check with some equal to 1, equal to 2. You can check if A greater than B. Print. So you can give something here. A is great. So this is an interactive mode. Next else you can print. So you can see. So it's giving A1, B2. Since it is this else print B is there. So here also you can work line by line. You can work here. This is one way of doing this. This is an interactive mode. Now the another one is the command line. So what you would do there is you can actually so this is the command line. So you can actually open command line and you can actually write .py files like hello.py. So I've created one hello.py. So I would execute and show it, and you can write in one file and you can actually run that .py file, and you can so what is there in what we have written in the file, so it would execute line by line and then it would give the output. So here it is showing okay, so the name was you can check out the names also here. So I have saved here in this file. So the name also should be like it should be correctly spelled. So give the name Python and the file name hello1.py. So I have written something to print hello world in that file. So I will show you that file too. So hello world. So you can see Python, if you give this command and then give the file name, so it would execute what is present in that. So this is one way of doing it. And one more way is this text. This is also one software where you can do this. And ID PyCharm. This is also like one interface where you can execute these Python programs. And I would show you this Anaconda Navigator, how we would go. So this is the most widely like used for data science applications. We use this. So we have all this Jupyter Lab and Jupyter Notebook, Qt console. You can do everything like Python, mainly for Python distribution. So this has been designed for Spider, VS Code. So you have here VS Code also, as I said earlier. So all R Studio, you can do the R programming also here. So this is very easy to like you can manage the libraries and all. Or for example, if you see the environments, you can create your own environment with particular version. So some libraries would be there inside. So for each particular library, you can check like if you wanted to install only particular version of that library, you can actually create your own environment and you can actually install the what you wanted, like which version you want. You can install that and put it in that environment, and you can run your code on that particular environment. So it is actually more user friendly, and you can actually manage your packages and all here. It's easy to interact also, so visually also. So These are all the different controls where you can implement your Python programs. These are all the different IDEs here. So next, now we would see what are all the different libraries that are mainly used here. So I was talking about different libraries here. So what are the different libraries we have, like we mainly use for implementing any kind of machine learning task is like one is NumPy. It's very popular. Like it's for, why do we need this libraries in places like for large multi-dimensional array and for matrix processing, this NumPy is very useful. And for like fundamental computations and all, this NumPy library, it has already inbuilt functions, and also for dealing with multidimensional array and matrix processing, this NumPy is very useful. And this SEIPY is for like, it contains different modules of optimizations for linear algebra, integration, statistics related content is all. The functions are present in SEIPY. So this library is needed when you, if you wanted do something regarding statistics and optimizations related tasks. And this SCI kit learn is for like for classical ML algorithms. You have already, like I've said, so there are basic algorithms in supervised and unsupervised. So those are all already present in this SCI kit learn modules. The functions are already available. So you can just go, you can just import this library, install this library first step, and then import it, and then you can use it. So we would see that also in the next coming slides. How do we import? How do we install and all? And next is Theano. Theano, it's mainly for like mathematical expressions where you have to involve with multi-dimensional arrays in an efficient manner. So this library helps in that, like for mathematical expressions to evaluate, to optimize the mathematical expressions, use this Theano. And next is TensorFlow. It is also very popular. It is developed by Google Brain Team in Google. And in this framework, there is an actually they define and they have run computations using tensors. So that for the computations also, it is very helpful. And next, coming into like, it can train and run deep neural networks also. This TensorFlow is very helpful in that, and it's been widely used in research and many applications also. This TensorFlow is very important. And next is the Keras. It is like on top of this Theano and TensorFlow, this Keras works. It can actually both be used by CPU and GPU. And it is for fast prototyping, you actually use this Keras also. And PyTorch is like an open source library based on Torch. Here, it is actually it's an ML library, that is machine learning algorithms library, and along with that, it has implementations in C with a wrapper in Lua. So wrapper functions are like decoratives. So they don't actually, they change the code, but if you wanted to delete that, you can delete it and you can place the base as such. So this is one such library, PyTorch. And pandas, so for any machine learning, so we deal with lots of data, so for data processing, preparation, so for that kind of data analysis purpose, we use this library pandas. So this is also important. So TensorFlow, so pandas, so depending on the application we go with, so each one of them are widely used actually. So this matplotlib, we can see this is mainly for data visualization. So if we wanted to see the plots, graphs, like to visualize the patterns in the data. So in the data, you do have some particular patterns. So to visualize of them, you need to have this matplot library also be installed in this. And actually, how do we install these libraries? We have this question. So we have something called pip. It's a package management system where it is written in Python and it's already there. So you need to just install it. Pip, like normally when you install Python, it also comes along with it. And if you wanted to update it, like if there is an updated version, so you can just give pip like you can upgrade it also. And using this pip, you actually you can actually install these libraries also. For example, pip install TensorFlow, and you can give in the command line, so then that gets installed. So if you wanted to install a particular version also, it is possible. So you can just give pip install TensorFlow equal to 1.14.0, so that particular version would get installed. And if you wanted to remove some like remove some libraries, you can also do that, and installations also. So these installations and installations are all actually easy to do it in the Anaconda Navigator. So that is more user-friendly environment where you can do all this things. So I would suggest go with Anaconda Navigator. So wherein you can use a spider or Jupyter notebook. Now next we would discuss with an example. So first, I would go with a simple linear regression example where it is a statistical approach. We can model the relationship between the input features and the output. So you actually frame a relationship between some input features and some output features, but whereas you do it in a linear model. So you have a linear line here. You have like y is equal to mx plus c. So you design what is m and what you based on the input you give what is m and what is c. So in the real life examples where this linear regression comes to predict sales of products. So how is it going to be in the future? How is the sale of this particular product going to be there? So based on the previous data and the existing like previous earlier sales and also based on that it will assess and give us the prediction. And for the economic growth and to predict petroleum prices, to predict the emission of new cars. So all this, and since why we're going for regression here is these are all continuous. As I said earlier, if we wanted the output or response to be on a continuous variables, we go with regression. And in the similar way, there is some project that's been done by BTech students also, like prediction of COVID-19, like how is it going to be there, like third wave, like how many people are going to get affected. So that kind of prediction also they have done using this ML algorithms only. So in real time, it is actually this has become a an advantage, and it is aiding human to perform better and in a good accurate manner. So in many companies also they have claimed that by using these AI/ML techniques, so their efficiency has also been increased to nearly 40 to 40% over the last few years. So so this technology has come to such place. Now I would go and explain with a code so that you can have a better. So and like I won't go very deep into this, so I would explain so what is what in this and how we are going to do this so that it would give an idea and you can further go and work on it. So for example, so this is a Python dot. This is a spider. So from Anaconda, I've clicked on I went to the spider, and this is the programming. This code has been written. So as a first step, what we are actually doing is here we are trying to predict the CO2 emissions based on the engine size. So based on the engine size of particular car, what is the emission, like how much CO2 emission would be there for like per kilometer, how many grams would be emitted. So we do have some data set based on this. We have this data set. So this is the make and this is the model, and we have the engine size, cylinders and all. So these are all the different features like fuel consumption, how much is the fuel consumption, like in the city, how much in the highway, how highway, what is the fuel consumption. So these are all the different fuel consumption features. And this is the engine size. So based on the two engine size also has an effect on the CO2 emission. So this is all the data set we have. So BMW, so all this data is available. So now I'm using this data to analyze. So for a new, like I have got a new car with some engine size. So I would like to predict what is the CO2 emission in that. So based on this data, I'm going to evaluate so the CO2 emission. So how we are gonna do that is first thing is like you have to import the required libraries first. In the first step, you have to import the required libraries. Like as I said, pandas you need it for data preparation, data like analysis. You need this pandas library. So here I'm importing this library, pandas. So like before importing, you need to install them. So you can just give your pip. So as it has already been installed here. So pip install pandas. If you give, it will install the latest version there. So since it was all now, or else it would throw an error here. So if you like, it would throw no module found. So then you can go and check in and install it again. So that's how it can be done. And now this, instead of pandas, we can just write PD everywhere. If you want, like instead of using this long names, you can just give PD in the rest of the code. Import numpy math.library. So these are all the libraries I'm using in this code. So I have imported. So first step is importing the required libraries. And second step is we had the data file. This is a CSV file. And so now I have to read this data file. So how do we read this? Is pd dot. So we had a command read underscore CSV and name of the file you give here, fuel2.csv. So you're giving the input file here, and that the data in the file will be stored in this data variable data. And this data dot head will give it in the row wise. Row wise you get all the data. So if you just click data here and check. So it's giving me the engine size and CO2 emission. But we had 7,385 like data sets into 2 columns. And because I'm accessing, you can see here only 2 features I'm taking. One is engine size and one is CO2 emission. So the data that is being there in these two is being stored in this data. So that is what I'm getting here: engine size and CO2 emissions, and these are all the different rows present. And here is just a plot that we have made based on this engine size and CO2 emissions. So you can see the plot here. So this is the engine size and CO2 emission. This is called the scattered plot. You can just give t.scatter. So from this, you can see if the engine size is this, what is the CO2 emission. So that kind of information we can retrieve from this. And next step is you have to generate the training and testing data from our data. So we have this whole data file, we have this data. So from this data, you need to separate out some part as training, some part for testing. Because when you train with some data, you cannot test with the data that is present in the training data. So you need to separate out. And when you're doing training on some data, you have to test it with the data that the machine did not see earlier. So that's how the accuracy of a model will be tested. So now you're splitting the whole data into like 80. Here they have done 80% is used for training and 20% we are using for testing. So it's your wish. You can use 70% for training and 30% for testing. So there are different ways to do that. So that is this step is to we are dividing the training and testing data. One is we are dividing 1 to 80 to train data, and 80 to 100 like we are giving it as a test data. So 80% we are giving training, 20% we are giving for testing. Next, as I said, this is a linear regression model. So I am using a linear model. So from the sklearn. So I said in sklearn, that is scikit-learn, we do have predefined ML algorithms already. Built-in functions are available. So I'm making use of that package here. So linear model, linear regression. So now this training data we are giving, like engine size is given, CO2 emission is given, and we are trying to fit the data, train X and train Y. So in this in this data fitting, what actually is being done is it accesses the input for simple data, like sample data is taken, and it also accepts the corresponding labels. So the preparation of the data is being taken in place here, and you're just printing this coefficient intercepts. And this is also similar way plotting. So the main thing is here you are making the model ready. So you have imported from the sklearn this linear regression model, and you have just plotted here this thing. You have fitted the data here. That is nothing but like training. So you have trained the data here actually, but since it is already available, you need not do anything. You can just call that live function from that particular sklearn library. So this fitting has been done. That is like here inbuilt the training has been done, and now you need to predict if your model is predicting good or not. So you have testing this. So you're giving some sample size of 3.5, and you're estimating that particular engine size. Based on the engine size, you are estimating the CO2 emission here. So we can actually run it and also check. So here you can see the coefficients and intercepts are these values and estimated estimation. So for this particular 3.5 engine size, we had this much of emission of CO2. And there are some terms like MSE. So we can actually check the accuracy of the model by using this MSE, MAE, that is mean absolute error, and R score. So these are all the different metrics for calculating the accuracy. So this is how like a simple regression model works. Like we just first import libraries, and then you prepare the training and testing data, and then you give it to a model, and you're getting it an output. So this is how the simple linear regression model works. And next, going into classification part. So you wanted to classify, suppose for example, if you this is an example for like I have taken a data set from CIFAR 10, so where you have images of aeroplanes, cars, and like horse, ships. So you have 10 different categories of images, and they're all 32 cross 32 sized images. So now here what we are doing is, so we need to classify that whether we should we should be able to name them when it do, like when a new image is giving to the mission, so it should be able to give the prediction. So that is being done using this neural networks here. So so I would just give a brief intro about this neural network. So actually there is a lot to learn deep inside it. So since we don't have time, so I would give just an overview on this, so that later on you can go and check what is what deep inside what it is what's happening. So here in neural networks, you can it is as I said, it is a subset of ML, and in DL we are going to use this. It is the heart of deep learning algorithms. See, in deep learning algorithms, we do have this neural network. So it looks something like this. So we have one input layer, hidden layers, and output layers. So this structure itself, you can see and say that it's more of inspired by the human brain. So this like biological neurons, like how the neurons in our brain signal to one another. So in the same way, the neurons here, we call them neurons here. So they're connected to each, synaptically connected to each other, and they send signals from one neuron to another. So based on this input, it actually does that operation. So it's more of a human brain architecture. This architecture is more similar to the human brain. And in this neural networks, you have something called forward propagation and backward propagation. So how actually this machine is learning? So that is how that is mainly through this backward propagation. So first I would explain about forward propagation. That is like if you are moving from like when you give a data, so it inputs here and then you get something output. So now this output layer, when you're moving from right to left, that is if you're moving from this side to left side, so that is called backward propagation. So basically what we are doing is, here we are correcting the weights to reach the minimized loss function. So there are some new terms here: loss functions, optimization algorithms, and also what is this loss function? So how do we arrive at optimum parameters, optimum weights and biases in the neural network? So that is being done by this loss function and optimization algorithms. So like in any case, main objective would be to minimize loss. So in any case, loss function or cost. So our goal would be to minimize the loss. So suppose for example, if you have given an input, say cat image, and then you have bought some, like it is saying at the first instance, if it is saying dog, so that's an error. So you calculate the error between them, and you try to minimize that error, and you try to bring it to output it as a cat. So so that's what, like you are trying to minimize that error, you are trying to minimize that loss. So but how do we minimize the loss? So minimization, so loss, we have a loss function and we have to minimize it. How do we minimize this? We do have some optimization algorithm. So like from like math, we can see like how do we minimize. You calculate the slope, that is you calculate the derivative, and then you equal to 0, and you find it out the minimum and corresponding maximas, right? So in the similar way here, for minimizing the loss function, you do have some algorithms like stochastic gradient, nested momentum, and Adam. So there are different algorithms. So basically in those algorithms, what we do is we calculate the slope, we calculate the gradient, gradient, and according to the gradient value, we keep on updating the weights. So that is how at the end, like after proper training, that is after giving multiple input sets of data, we are actually arriving at a prediction. So these are all just the terms. Just I'm giving it an overview. So if you have to understand it better, so you have to dive deep into it to understand what is actually happening inside this back propagation algorithms, optimization algorithms, loss functions. So this is how it should go on. So like for example, if you initialize your weights with some random values, and you then calculate the loss or error term, and you try to minimize the loss in such a way that these weights get updated. So this is what this neural network is being done. So you're giving some input, you're getting some output, and you're trying to minimize. So if you're getting exactly, so there won't be any error. So error would be zero, and you need not minimize it. But in the true case, like you don't get the true value anyhow. So you're trying to minimize that loss function, and you're trying to come to a optimize those weights and biases such that you get a proper output. So this classification also I would like to explain with example. So I would go with an example one more. So this is the classification example here. In the same way as I've said earlier, first step is you import libraries. And this is, as I said, the CIFAR 10 data set where you have 10 categories of images, and it's of size 32 cross 32. So in any model, in any like algorithm, first step is you need to import libraries, and then you have to prepare the data. Here you can see first step is I have imported the data, and then I have loaded the data into this variable. This is Ziparton. This is actually available in this TensorFlow API, so I can directly download it while running. So, like earlier, I have given explicit the file name. Here, we need not give like that. It's already present in this library, so we can directly download it. So, this is how this data is being loaded. And next, you are distributing it. As I said, we distribute some percentage of data to training and some percentage to testing. So, we can actually here we are actually doing that division part. And next is as I said, like we do some preparation. So this is an image, right? So we have a pixel value of like 1 to 250 255. So you're normalizing it here, so that is you're bringing it those values to 0 to 1, so that it would be easy for the mission, also for the computation. So if the values are larger, then you the like load on the mission increases, so you are actually reducing the pixel sizes here. So you're dividing by the maximum size so that the value comes in between 0 and 1. And also one more thing to say, in the CIFAR data, we have 5,000 training images and 1,000, like we are dividing in 5,000 training images and 1,000 test images here. And each is of size 32 cross 32. And I will show you the diagrams also here. So this is how they look. Since it's 32 cross 32, we don't have good resolution here. But this should be enough to make some classification. So these are all like some 25 images example. Like we do have 5,000 actually, 6,000. So in that just 25, I'm displaying it here for reference. And now this processing is happened. That is, we have prepared the data, and then we have flattened the label values also. That is the output. We are actually making it like a vector format, a single vector format label. We have 10 categories, right? So 10 labels with 10 categories are there here. So you're making it actually into a row kind of a pattern here. Next, what you're doing here is it's just for displaying purpose. This is for displaying these images. And then next, this is where this, like earlier we had directly imported the function from the library, but whereas in here you're explicitly defining the network. So each layer, suppose you have some architecture. So based on that architecture, this is a neural network architecture, convolutional neural network. So you are explicitly defining the network here. This is all network definition here. So you have 3 sets of layers: convolutional 2D layer, batch normalization, max pooling 2D. So these all comes under convolutional neural network. So where for the images we mostly use the CNN to extract out features and to get good accuracy. This convolutional neural network is being used, and there is a purpose for each layer here, for like max pooling, batch normalizations, convolution. So it's a set of series of operations that needs to be performed. And then at the end, this is all network definition. So based on your design of architecture, so you can actually define how many, like depends on the application, you define the layers also. So it can be 2 layers, 3 layers, 4 layers. So if you want your algorithm to like deep, we say deep neural networks also. That is like you have many number of layers deep inside it, so that we get a good prediction. So, but at the same time, computational complexity also would be there. So you need to check the trade-off between all these parameters when you're designing your own architecture also. And next here, what we are doing is we are now compiling the what do we say, compiling the model. So in compiling means what actually we are doing is we are preparing everything ready. Like we are giving what is the optimizer we wanted to use. As I said, IW is optimizer, like to calculate the gradients in the back propagation step, we use this optimizer. And what is a loss function? So there are loss functions like mean square error, cross entropy loss function, scale divergence. So these are all the different loss functions. So to calculate the like what is true minus predicted value, that is what loss. So that loss we can define it in many ways, like using this cross entropy, mean square error. So we do have many losses. So here in this code they have used cross entropy. And the metric is accuracy. We have accuracy, validation, loss, validation, accuracy. So we do have different metrics. So among that we were using here accuracy. And after compiling, we are actually fitting the model. That is, we are training. The training part is happening here. And there is something called epochs here. So epochs is like the number of times the model run, like the algorithm runs over your data set. Suppose I have this 5,000 training samples. So here I gave number of epochs as 1. 1 means it will pass through the entire data set once. But as here for demonstration, I gave 1, but you have to give it like say some 50, 100. So to enhance the performance, this epoch should be like increased, like the number of times your algorithm runs through the training. So suppose if you're giving 10, it means 10 times you're running through the system. So next, so this is how you're fitting the data and running. So I would run it and show. So you can see this, if the training is happening on 5,000 samples and validation is happening on 1,000 samples. So I just gave 1 epoch because like if we give more number of epochs, it would take time. So for demonstrating, I'm showing it with 1. So you can see this, it's happening. So 1792. And here you can see the loss also, and time, estimated time also, loss, and what is the accuracy till that time we are getting. So all these parameters also you can see it here. And also while like you need you can actually check on this, what is this optimizers, what is this loss function, so architecture. So these are all the main areas in this like if one is learning about this machine learning or deep learning architectures or models and thing. So this is going on. So if you have any questions and all, you can just put it in chat box, so we can check and answer them also meanwhile. So I would, in course, I would also give like what actually we are doing with this So here you can see the seismic exploration. So like this, what is the seismic exploration is like for you have like we have crude oil or natural gas or minerals deep inside the earth surface. So here we need to know which mineral is present inside the earth surface. So we actually cannot dig everywhere. Like we would want to know, we cannot dig it and we cannot check it. Like we cannot dig bore wells everywhere and we cannot check it. So what they're doing is they would set up some vibrator trucks here, and a series of geophones are placed on the earth surface. So when a like vibrator, in the sense here they send a sound pulse, and the sound pulse when it goes deep into the layers, it gets the sound waves get refracted and reflected, and then they are getting received at the geophone. So that data we are collecting. So that with that data we are actually getting the information of what is present inside the layer. So based on the refraction, reflection coefficients, we can actually calculate the impedance values and all, and then we can actually know what layer is present, what mineral is present in each of these layers actually. So with that information, we will get to know what is present at what depth. Crude oil is present at this depth, rock is present at this depth. So we get that information from the seismic images that are being received from the geophones. But in this process of exploration, there is like one thing is noise. There is lots of noise that can be added due to the environmental disturbances, or there is some instrument noise, or during acquisition process if we have a noise. So we do have lots of noises also coming into this seismic images while we are receiving at the geophone end. So there, while we are receiving, we need for further processing, we need to denoise them first. As a first step, we need to denoise them. So for the denoising also, we are using this machine learning techniques for denoising. And not only for denoising, after denoising the data, we actually need to identify which mineral is which mineral from the data. From that data, we should be able to tell the which mineral is present in that particular layer. So that is called seismic inversion actually. So that is also being done nowadays with this machine learning and deep learning techniques. So this is one such applications where now we are working on. That is on one is denoising and another is seismic inversion. So like if uh, so this is one such application where we are actually working on this. And there like another area like which is very like popular is medical field also, to diagnose and like to I detect for detection and diagnosing the medical conditions like autism and like cancer. So there are many they're using nowadays this ML techniques, and there are many projects that are going on also in this field, and the research is going on in this field, so that it actually aids the doctors also to cure, to get cured, to give a good diagnosis for a particular medical condition. So these are all the different applications where this is being widely used. So actually, after this training process is done, we are actually we are testing the model also with using this. You can see here. You can see here original predicted label. So you are actually predicting you're giving some input from the test data, and you are actually predicting the label. So I think it's taking time. It's already 12. So I think I've already run one. So I have given this as an input, and it actually gave me let's say cat. So this here 32 cross 32, it's so not visible like clearly. So it would give me like an output cat. So it, but to increase the accuracy, you need to actually give like you have to run the training, like you have to run through the training data set multiple times. That is, the number of epochs should be more to get a good accurate like prediction. So this is like one such example. So this is the area, like I've said, we are working on. So you can see this. This is live, like onshore 2D seismic, like on land. They are taking the data using geophones, and this is offshore. So in like in the seas or under the seas, beneath the seas, also we do have crude oil, and also for that, this is the acquisition process that they are sending the signals, and they have the area of geophones where they're getting collected. And next, this is with vibrator trucks. So we do send the pulses. So they use some cases they use dynamites to send a like sound pulse deep into the earth, and sometimes they use this vibrosis trucks and all. This is the geophone. This is actual geophone that through which we receive the data. So that data is being processed now. So this is an application where ML, and not only this, you can actually work deep inside this neural network. Like you can try to change the architecture, loss functions, loss or objective function, and different interpolation techniques are also being used deep inside this neural network. So that to enhance the performance, also that like that kind of research is also happening. So if you are like anyone is interested to work on this, you can contact, or you can, if you have any doubts, you can mail us to these IDs. And thank you, and hope this session was like helpful for you all. So this is just an introductory session. So it, like, if you have to go deep into it, it takes more sessions. So like you can now, I think I've given a like overall view of what is what. So you can Google and go on, check further on this topics. Thank you. Thank you so much.
Okay. Thank you, Vanilla, for your excellent talk on this AI/ML with Python. Hope to get more talk, and I would like to request all the participants, if you have any question, we will just quickly take up some of the question, and our panelists would be able to, speaker would be able to give you the answer. Or you can also mail us about your queries and doubt. We would love to help you out. Thank you very much. Thank you very much, Vanilla, for your talk. Okay, so let us. ITKM, hello.
Yes, sir.
Amal, are you there?
Yes, sir.
Okay, okay. So we are done with from our end. Thank you very much. Hope to come up with another lecture with different title. Thank you very much.
Okay. Sir, could I end the session?
Yes, yes, yes.
Okay.